phone is just not necessarily the easiest. So I'll go student view so we can see. So yours should look just like this, just without the purple border. I feel like a lot of us have a bunch of things over here in the city pile. You're gonna go to the current chapter, which will pop us down to module 6. And we're gonna go to today is 3:18, which is called Con and Flyers. Just the equations. It was in class the looking at the catapults. Yeah, putting our equations in. I saw your equations on there. Okay, so what we're gonna do is we're gonna go to this link right here, and it's gonna pull up a page that looks just like this. And what you're gonna do is you are going to, on your paper, you're going to switch the word purple to A. You're going to switch the word red to an H. And you're going to switch the word blue to a K. It does not make sense to learn things based on the colors of an arbitrary graph. So what I want you to do is I want you to use these little buttons off to the side. Hang on, switching back. You're going to grab these little blue dots, and you're going to slide them around. You're going to grab these little blue dots and slide them around, and see if we can figure out what A, H, and K do. This is based on our A, H, K vertex form here. So see if you can figure out a way to describe what A, H, and K each do. So just take a couple of minutes and see if you can figure out what A, H, and K do. No, we're going to write it in your book on page 91. We're going to switch. I'll go back to that page that says it. There we go. Go to the Canvas page. You see a lot of us that have not even logged in. You're not. Oh, we could use our words.
Because it's like you hold a baby back, don't you? He actually walked on my computer like this. You see the strap is supposed to be right here. Wait, don't you hold a baby back?
Literally have it 90 degrees off. This goes on the keyboard so it's not blocking your screen. There's these that are meant to go on the corners of your screen and not block your view. No, I'm saying you removed it. You put it back in so that you wouldn't get in trouble for drop protection. Like this. These go like that. So then they don't block your view of your whole screen. These are like brand new. They are unstretched. I know. I can tell. And that way, it's not like super tight on your hinge.
You didn't know that.
His is like that.
Ooh, it's not fair.
Have you ever feeling you removed yours from your realized it was no longer insured against
Yeah, quite next to that. I think
that's
actually-
trouble.
I think that's
Because if you walk around without it in its case and it breaks, you are then responsible for the breakage. If it is in the case, you are not responsible for the breakage. Yeah, seriously. It's part of the insurance that we have on the computers. It's literally in the contract y'all signed when you got them.
You know, sometimes people just sign off. It's not good.
It was a single page. It wasn't even like terms and condition from Apple, which is like 30 pages. It was a straight up single page contract. It even lists out the price of the damage. Because I think like replacing a keyboard's like 50, I want to say it was like $50. So like it lists out the cost. All right. So what do we think? What does our A do? What word did we put that to? What does changing the A value do to our graph? What does this do? This slider, our A slider. Mm-hmm.
What's the word? The word is
Uh-huh.
compress.
Compress. So if our A is little, oops, come on. No, not what I meant. So if our A is little, like between 0 and 1, it does something what we call compression. It's so cute, I want to squish it. It's so cute, I gotta squeeze it. So if A, and the way we write this is, whoa, sorry, zoomed in, follow my brain here. So this would be for part A. If the absolute value of A is less than 1, meaning it's between -1 and +1, then it's called compression. So if it's a little baby fraction, it's been compressed. If A is a big kid number, so if A is bigger than 1, what does that one do? So what happened when A got bigger? It stretches. Come on, there we go. So it gets tall and skinny. I think about it as it's a big kid now, it's doing big kid yoga. It's stretching up tall. I'm gonna put it back on our 1. Oop, that one. So if A is bigger than 1, it's a stretch. What happens when A is negative? Because it goes boop. Stop trying to make me type things. Boop. So here's our -1, mostly. It reflects across the x-axis. If A is negative, it's been reflected. Across the x-axis. So these are all options for what A does. And even when it's down here and reflected, it can still compress when it is littler than 1. It's still getting so cute. It's like somebody sat on it. It's so small and cute, I could squish it. Squish. Looks like somebody sat on it. Squish. It still can stretch even if it's reflected. Oh, come on. We're going to get this right on. No. Come on. There we go. All right. So now let's look at part B that we said was red and we changed red to H. What does H do? Shifts more specific, be more specific. Left and right. It does a horizontal shift. We can just make this whole thing just dance side to side. It doesn't change the shape of my U at all. Even if it is stretched, it still does this. Even if it is compressed, it still does just a horizontal shift. So it doesn't really change anything except the horizontal shift. So my H does a horizontal shift. It's what tells us if it moves left or right. How about our K? What did our K do? A vertical shift. It moves it up or down. So then it asks some very strangely worded questions. They say, which of these affects the range of a parabola? What is the range? Again, which is it, X or Y? Y. So which of these affect my Y values? The K. Why does the K affect it? It's not the y-intercept. Because it moves up and down. It determines, so if I put it right on 2, it's determining the y value of my vertex. So no matter what, whether my A is positive or if it's negative, my K is still involved with my endpoint. So my K is the y value for my vertex. So it's going to always be the boundary on our range. It's always going to be either our very highest or our very lowest. Which other one affects my range? A. Because A is going to tell us whether we're taking our vertex as a maximum and looking at everything below, or if our vertex is a minimum and we're taking everything above. So our A tells us which direction. If A is positive, so I'm going to say if A is greater than 0, then our range is going to be that Y has to be greater than K. If A is less than 0, meaning it's been reflected, so my whole shape is down here, my Y's have to be less than my K. We're not going to do a ton with that, but it gives us kind of a rule to follow here. This is 2 thoughts. Okay, so then what we're going to do is we're going to take our equation 1 times x minus 0 squared plus 0. So I want you to take all your sliders and get them there. So we're going to take our A to be 1. So get your slider at 1. You can also type in if you want to, if you're not too great at sliders, which I'm struggling. There we go. My H at 0. And my K at 0. Ooh, come on. I am really bad at getting it right on it. There we go. And what I want you to do in the space for number 2 is I want you to find 5 points on the graph. If you want to scroll it, you can. Like you can move things and do this. I want you to find 5 good points on this graph. We're not doing decimals. If you click on the graph, oh, it's not going to let you click on it. Or at least it's not going to let me click on it. You might be able to get a point on there. but I want you to get 5 points that we're not guessing on decimals. Okay. What did we have? What were some of your points? I'm going to put some more space up to the right. I'm going to put them in a table. What points did we get? What are some points on this parabola? 0, 0. There's a fine point on this. I'm going to put it right in the middle because it's right in the middle of our graph. What's another point on this graph? One, 1. Is definitely another point on this graph. So we've got our 0, 0. We've got our 1, 1. I'll just write them on this page so we can actually see stuff. So we've got our 0, 0, our 1, 1. Where else do we have nice tidy points? 2, 4. Let's just go right there. Where else do we have points? Negative 1, 1. And one more point. 3, 9. Up here. So when we are looking at parabolas, we kind of make it always easy on ourselves if we see our vertex, because we know that's going to be in the middle. And so I always put that in the middle of my table. And we want to have at least a couple that are smaller and a couple that are bigger. And when we're looking at our table, we should always wind up with symmetrical data. So I know 1, 1 is a point, so negative 1, 1 is a point. I know 2, 4 is a point, so negative 2, 4 is a point. Because these are always going to be symmetrical. Always going to be symmetrical. We could do the same thing with our minus 3, 9. It's always going to match. So when we did this back in Algebra 2, I'm just going to write our points down here. 2, 4, negative 1, 1. You have to memorize this. Because we used this parent table. That's what this is called. That was our parent function. So this is our parent table. We used this with our vertex form to make the graphs. Because we would take our parent function and pick it up and move it according to our transformations. We would move it left, we would move it right, we would move it up, we would move it down, we would compress it, we would do all those things. Because what you're going to do next is we're going to make some sketches of some transformations, and we're going to try and either make tables and make graphs, or remember how the transformations work, whether we're moving left or whether we're moving right, moving up or moving down. So you're going to look at page 92 to do this. If you're wanting to make tables, like proper tables, proper graph as opposed to a sketch, this should feel familiar if you did Algebra 2 here. We take our x plus h, y, a plus k. If you want to make tables for this, this is how you do it. We're going to take our parent function and apply our transformations. If you just want to sketch and move our parent function left to right 2, up 4, down 4, whichever one it is, that's what I want you to do. We're going to make a sketch of these equations here and see if we can figure out how it's going to move. So that's these ones here. These are the ones on page 90. You're going to look at page 92 and 93. I want you to see how it changes from the parent. See if you can figure out what the transformations are. I know they're very blendy in here on this salmon color up here. They're also written on page 92. So I want you to try and do this. Take at least one of them and identify your transformations and see if we can get yourself a little sketch going. There are graphs on page 93 that you can put them on. Bless you. But that's what we're going to do for the rest of the time is I want you to try and sketch those. If you are a perfectionist, you can go ahead and properly graph them. But all we're looking for is a sketch because we want to see if we can figure out the transformations and the range. So see what we can think about, what A, H, and K do, and what these are telling us about our graphs. Okay? And if you want to use that slider, you can. See what's going to happen. Try these things. Mess with them. We'll talk about them in a couple minutes, or in a few minutes. Okay? I'm going to give you some time to look at this. See if you can figure out how it's being transformed and what your range is going to be. What's that?
Alright, so what's the difference between having one and a number that's greater than one? When we say that one is a structure equation.
So 1 is basic, like she didn't do nothing. She did what she did, what she paid. When it's big kid yoga, so if it's bigger than 1, it's gonna go up and all stretch because it's a big kid doing yoga. And when it's little, it's just so cute. Oh, it's compression. Squish it like a sandwich.
Oh, we can determine that P value by being on there. Right.
Sketchy sketch. I give you graphs, so make me pictures. I want pictures.
Causing problems. Fixes it. Thank you. Causing problems. Cords go on floors. Or I go back. I think I have a still go over, and I don't. I can't even stand well. This was from a hoverboard. I have a plate. Because I'm good at standing.
All right, let's talk through these just a little bit. So if we think about the first one, what do we know about an equation like this? Yeah, the first one. The x minus 2 squared plus 4.
Go up 4
Yep, it's been moved up 4.
to the
Right 2.
and we know that the A is 1.
We know that our A is 1, which means it's going to be happy face or frowny face? Happy face, our concave up. So we know it's going to be like this with our vertex at 2, 4. So even if I know nothing else, I do no substituting and I do no sketching, what is our range here?
You said it's the Y.
The y values.
So
My y's have to be, what, greater than or less than? Do we have a maximum or do we have a minimum? My vertex, is it a low point or is it a high point?
on this graph,
On this graph,
low point,
it is a low point. So do we have a minimum or do we have a maximum? Minimum. So my y values have a minimum of 2. Are they going to be bigger than 2 or are they going to be smaller than 2?
smaller. I'm not sure.
If my minimum value is 2
Oh, never mind.
on my y's, so would 3 be valid as a y value? Could I have a y value of 3 and hit my graph somewhere?
Yes.
Could I have a y value of 1 and hit my graph somewhere?
No.
No, so my y values have to be what relative to the 2?
Bigger.
Bigger than or greater than. So my y's have to be greater than or equal to 2. Let's look at the next one. I'm going to give us a little bit here. Let's look at the minus x plus 3 minus 1. Same vibe. What are our transformations here? What do we know?
Down 1.
It's been moved down 1. My k is minus 1. It's been flipped. It's been reflected because of this a. How about my h? What's my h telling me? Left 3. So I'm going to do this one in this kind of white space over here. So I know it's been reflected, so I know we have a frowny face or concave down parabola. And I know my vertex, h comma k, I know my vertex is at negative 3, negative 1. My left 3, down 1. So let's think about our range.
It's a high point.
It's a high point. So this is a maximum.
You gotta be less.
So my y's have to be less than or equal to what? What's my value?
Negative.
Negative 1. We're looking at my y value, so it's always going to involve my y value. Okay, so that's kind of the vibe we're looking at here. You don't have to do pure and proper graphs. If you want to, you can. That's what the graphs on 93 are for. If you want to do our full A, H, and K transformation table, get proper points, plot them up, and see them that way, you can. Okay, but we're going to work more with graphic stuff as needed later on. Okay, so questions on these. I'm going to leave the last two for you guys to keep working on. Because, you know, we still have 10 minutes. So I want you to look at these last two and see what's different and what changes. And then tomorrow we're really going to start looking at solving stuff, getting to x equals. Okay, so I want you to keep looking at these next two, see if you can figure out your answers, and go from there. Oop.